Introduction. Generative AI applications are built on language models. The development process usually starts with an exploration and comparison of available foundation models to find the one that best suits the particular needs of your application. After selecting a suitable model, you deploy it to an endpoint where it can be consumed by a client application or AI agent. Foundation models, such as the GPT family of models, are state-of-the-art language models designed to understand, generate, and interact with natural language. Some common use cases for models are speech-to-text and text-to-speech conversion. For example, generate subtitles for videos. Machine translation. For example, translate text from English to Japanese. Text classification. For example, label an email as spam or not spam. Entity extraction. For example, extract keywords or names from a document. Text summarization. For example, generate a short one-paragraph summary from a multi-page document. Question answering. For example, provide answers to questions like, what is the capital of France? Reasoning. For example, solve a mathematical problem. In this module, you focus on exploring foundation models used for question answering. The foundation models you explore can be used for chat applications, in which you use a language model to generate a response to a user's question. Note: the latest breakthrough in generative AI models is owed to the development of the transformer architecture. Transformers were introduced in the Attention is All You Need paper by Vaswani et al. From 2017. The transformer architecture provided two innovations to NLP that resulted in the emergence of foundation models. Instead of processing words sequentially, transformers process each word independently and in parallel by using attention. Next to the semantic similarity between words, transformers use positional encoding to include the information about the position of a word in a sentence. Explore the model catalog. 100 XP. 7 minutes. The model catalog in Microsoft Foundry provides a central repository of models that you can browse to find the right language model for your particular generative AI use case. Selecting a foundation model for your generative AI app is important as it affects how well your app works. To find the best model for your app, you can use a structured approach by asking yourself the following questions. Can AI solve my use case? How do I select the best model for my use case? Can I scale for real-world workloads? Let's explore each of these questions. Can AI solve my use case? Nowadays, we have thousands of language models to choose from. The main challenge is to understand if there's a model that satisfies your needs and to answer the question, can AI solve my use case? To start answering this question, you need to discover, filter, and deploy a model. You can explore the available language models through 3 different catalogs. Hugging Face, vast catalog of open source models across various domains. GitHub, access to diverse models via GitHub Marketplace and GitHub Copilot. Microsoft Foundry, comprehensive catalog with robust tools for deployment. Though you can use each of these catalogs to explore models, the model catalog in Microsoft Foundry makes it easiest to explore and deploy a model to build your prototype, while offering the best selection of models. Let's explore some of the options you need to consider when searching for suitable models. Choose between large and small language models. First of all, you have a choice between large language models, LLMs, and small language models, SLMs. LLMs like GPT-4, Mistral Large, Llama 370B, Llama 405B, and Commander Plus are powerful AI models designed for tasks that require deep reasoning, complex content generation, and extensive context understanding. SLMs like Phi 3, Mistral OSS models, and Llama 3.8B are efficient and cost-effective, while still handling many common natural language processing (NLP) tasks. They're perfect for running on lower-end hardware or edge devices, where cost and speed are more important than model complexity. Focus on a modality, task, or tool. Language models like GPT-4 and Mistral Large are also known as chat completion models, designed to generate coherent and contextually appropriate text-based responses. When you need higher levels of performance in complex tasks like math, coding, science, strategy, and logistics, you can also use reasoning models like DeepSeek, R1, and O1. Beyond text-based AI, some models are multimodal, meaning they can process images, audio, and other data types alongside text. Models like GPT-4o and Phi 3 Vision are capable of analyzing and generating both text and images. Multimodal models are useful when your application needs to process and understand images, such as in computer vision or document analysis, or when you want to build an AI app that interacts with visual content, such as a digital tutor explaining images or charts. If your use case involves generating images, tools like DAL, E3, and Stability AI can create realistic visuals from text prompts. Image generation models are great for designing marketing materials, illustrations, or digital art. Another group of task-specific models are embedding models like Ada and Cohere. Embeddings models convert text into numerical representations and are used to improve search relevance by understanding semantic meaning. These models are often implemented in retrieval augmented generation (RAG) scenarios to enhance recommendation engines by linking similar content. When you want to build an application that interacts with other software tools dynamically, you can add function calling and JSON support. These capabilities allow AI models to work efficiently with structured data, making them useful for automating API calls, database queries, and structured data processing. Specialize with regional and domain-specific models. Certain models are designed for specific languages, regions, or industries. These models can outperform general-purpose generative AI in their respective domains. For example, Core 42 JAS is an Arabic language LLM, making it the best choice for applications targeting Arabic-speaking users. Mistral Large has a strong focus on European languages, ensuring better linguistic accuracy for multilingual applications. Nixla TimeGen, one specializes in time series forecasting, making it ideal for financial predictions, supply chain optimization, and demand forecasting. If your project has regional, linguistic, or industry-specific needs, these models can provide more relevant results than general-purpose AI. Balance flexibility and performance with open versus proprietary models. You also need to decide whether to use open source models or proprietary models, each with its own advantages. Proprietary models are best for cutting-edge performance and enterprise use. Azure offers models like OpenAI's GPT-4, Mistral Large, and Cohere Commander Plus, which deliver industry-leading AI capabilities. These models are ideal for businesses needing enterprise-level security, support, and high accuracy. Open source models are best for flexibility and cost efficiency. There are hundreds of open source models available in the Microsoft Foundry model catalog from Hugging Face, and models from Meta, Databricks, Snowflake, and NVIDIA. Open models give developers more control, allowing fine-tuning, customization, and local deployment. Whatever model you choose, you can use the Microsoft Foundry model catalog. Using models through the model catalog meets the key enterprise requirements for usage. Data and privacy. You get to decide what happens with your data. Security and compliance. Built-in security. Responsible AI and content safety. Evaluations and content safety. Now you know the language models that are available to you. You should have an understanding of whether AI can indeed solve your use case. If you think a language model would enrich your application, you then need to select the specific model that you want to deploy and integrate. How do I select the best model for my use case? To select the best language model for your use case, you need to decide on what criteria you're using to filter the models. The criteria are the necessary characteristics you identify for a model. 4 characteristics you can consider are Task type. What type of task do you need the model to perform? Does it include the understanding of only text, or also audio, or video, or multiple modalities? Precision. Is the base model good enough, or do you need a fine-tuned model that is trained on a specific skill or dataset? Openness. Do you want to be able to fine-tune the model yourself? Deployment. Do you want to deploy the model locally on a serverless endpoint, or do you want to manage the deployment infrastructure? You already explored the various types of models available in the previous section. Now, let's explore in more detail how precision and performance can be important filters when choosing a model. Filter models for precision. In generative AI, precision refers to the accuracy of the model in generating correct and relevant outputs. It measures the proportion of true positive results, correct outputs, among all generated outputs. High precision means fewer irrelevant or incorrect results, making the model more reliable. When integrating a language model into an app, you can choose between a base model or a fine-tuned model. A base model, like GPT-4, is pre-trained on a large dataset and can handle various tasks but can lack precision for specific domains. Techniques like prompt engineering can improve this, but sometimes fine-tuning is necessary. A fine-tuned model is trained further on a smaller, task-specific dataset to improve its precision and ability to generate relevant outputs for specific applications. You can either use a fine-tuned model or fine-tune a model yourself. Filter models for performance. You can evaluate your model performance at different phases, using various evaluation approaches. When you're exploring models through the Microsoft Foundry Model Catalog, you can use model benchmarks to compare publicly available metrics like coherence and accuracy across models and datasets. These benchmarks can help you in the initial exploration phase, but give little information on how the model would perform in your specific use case. Expand table. Benchmark. Description. Accuracy. Compares model-generated text with correct answer according to the dataset. Result is 1 if generated text matches the answer exactly, and 0 otherwise. Coherence. Measures whether the model output flows smoothly, reads naturally, and resembles human-like language. Fluency. Assesses how well the generated text adheres to grammatical rules, syntactic structures, and appropriate usage of vocabulary, resulting in linguistically correct and natural-sounding responses. Groundedness. Measures alignment between the model's generated answers and the input data. GPT similarity. Quantifies the semantic similarity between a ground truth sentence or document and the prediction sentence generated by an AI model. Quality index. A comparative aggregate score between 0 and 1, with better performing models scoring a higher value. Cost. The cost of using the model based on a price per token. Cost is a useful metric with which to compare quality, enabling you to determine an appropriate trade-off for your needs. To evaluate how a selected model performs regarding your specific requirements, you can consider manual or automated evaluations. Manual evaluations allow you to rate your model's responses. Automated evaluations include traditional machine learning metrics and AI-assisted metrics that are calculated and generated for you. When you evaluate a model's performance, it's common to start with manual evaluations, as they quickly assess the quality of the model's responses. For more systematic comparisons, automated evaluations using metrics like precision, recall, and F1 score based on your own ground truth offer a faster, scalable, and more objective approach. Can I scale for real-world workloads? You selected a model for your use case and have successfully built a prototype. Now, you need to understand how to scale for real-world workloads. Considerations for scaling a generative AI solution include model deployment. Where will you deploy the model for the best balance of performance and cost? Model monitoring and optimization. How will you monitor, evaluate, and optimize model performance? Prompt management. How will you orchestrate and optimize prompts to maximize the accuracy and relevance of generated responses? Model lifecycle. How will you manage model, data, and code updates as part of an ongoing generative AI operations, Gen AI Ops, lifecycle? Microsoft Foundry provides visual and code-first tools that can help you build and maintain a scalable generative AI solution. Next unit, deploy a model to an endpoint. Previous next. Need help? See our troubleshooting guide or provide specific feedback. Deploy a model to an endpoint. 100 XP. 5 minutes. When you develop a generative AI app, you need to integrate language models into your application. To be able to use a language model, you need to deploy the model. Let's explore how to deploy language models in the Microsoft Foundry after first understanding why to deploy a model. Why deploy a model? You train a model to generate output based on some input. To get value out of your model, you need a solution that allows you to send input to the model, which the model processes, after which the output is visualized for you. With generative AI apps, the most common type of solution is a chat application that expects a user question, which the model processes to generate an adequate response. The response is then visualized to the user as a response to their question. You can integrate a language model with a chat application by deploying the model to an endpoint. An endpoint is a specific URL where a deployed model or service can be accessed. Each model deployment typically has its own unique endpoint, which allows different applications to communicate with the model through an API, application programming interface. When a user asks a question, an API request is sent to the endpoint. The endpoint specifies the model that processes the request. The result is sent back to the app through an API response. Now that you understand why you want to deploy a model, let's explore the deployment options with Microsoft Foundry. Deploy a language model with Microsoft Foundry. When you deploy a language model with Microsoft Foundry, you have several types available, which depend on the model you want to deploy. Deploy options include standard deployment. Models are hosted in the Microsoft Foundry project resource. Serverless compute. Models are hosted in Microsoft-managed dedicated serverless endpoints in a Microsoft Foundry Hub project. Managed compute. Models are hosted in managed virtual machine images in a Microsoft Foundry Hub project. The associated cost depends on the type of model you deploy, which deployment option you choose, and what you are doing with the model. Expand table. Standard deployment. Serverless compute. Managed compute. Supported models. Microsoft Foundry models, including Azure OpenAI models and models as a service models. Foundry models with pay-as-you-go billing. Open and custom models. Hosting service. Microsoft Foundry resource. AI project resource in a hub. AI project resource in a hub. Billing basis. Token-based billing. Token-based billing. Compute-based billing. Note. Standard deployment is recommended for most scenarios. Next unit, optimize model performance. Previous next. Need help? Z model performance. 100 XP. 8 minutes. After you deploy your model to an endpoint, you can start interacting with it to see how it works. Let's explore how you can use prompt engineering techniques to optimize your model's performance. Apply prompt patterns to optimize your model's output. The quality of the questions you send to the language model directly influences the quality of the responses you get back. You can carefully construct a question or prompt to receive better and more interesting responses. The process of designing and optimizing prompts to improve the model's performance is also known as prompt engineering. Prompt engineering requires users to ask relevant, specific, unambiguous, and well-structured questions, instructing the model to generate more accurate responses. To understand how to create well-defined prompts, let's explore some patterns that help you improve the output of a model. Instruct the model to act as a persona. Guide the model to suggest better questions. Provide a template to generate output in a specific format. Understand how a model reasons by asking it to reflect. Add context to improve the accuracy of the model's output. Note: the patterns listed here are based on the work by White et al., 2023, who constructed a prompt pattern catalog. As a developer, an effective approach is to add instructions to your deployed model in the form of a system prompt. The system prompt sets the model's behavior and allows you to guide the model without exposing the end user to the instructions. The best results are often achieved through the assignment of an explicit system prompt and guidance, or templates, that help users submit prompts that reflect the patterns described here. Instruct the model to act as a persona. When you want the model to take a specific point of view or perspective when answering a question, you can ask it to act as a persona. For example, you can ask the model to respond as if it's a seasoned marketing professional if you're working in sales and need insights about a new CRM software. Expand table. No persona specified. With persona specified. System prompt. None. You're a seasoned marketing professional that writes advertising copy for an audience of technical customers. User prompt. Write a one-sentence description of a CRM product. Write a one-sentence description of a CRM product. Model response. A CRM product is a software tool designed to manage a company's interactions with current and potential customers, encompassing sales, marketing, customer service, and technical support. Experience seamless customer relationship management with our CRM product, designed to streamline your business operations, enhance customer interactions, and drive sales growth with its intuitive interface and robust analytics tools. You can create different personas for various business roles. Think of roles like a product manager, data analyst, customer service expert, or teacher. Define the persona and add more detail to what you expect that persona to know or do to get tailored, context-driven responses. Ask for better question suggestions. When you want the model to help refine your question, you can ask it to suggest better ways to phrase your query. You can also ask it to provide extra context. For example, if you're seeking advice on cooking a meal, you can prompt the model to suggest clarifying questions to help you get a more targeted answer. Expand table. No suggestions given. With suggestions given. A system prompt. You're an AI chef who can advise on menus. You're an AI chef who can advise on menus. You're approachable and always want to provide the best advice you can. User prompt. I have to host a dinner party for 4 people. What should I cook? I have to host a dinner party for 4 people. What should I cook? What other information do you need to help me plan a great meal for my guests? Model response. Hosting a dinner party for 4 is a wonderful opportunity to showcase your culinary skills. Here's a suggested 3-course menu that balances flavors and provides a pleasant dining experience. Appetizer caprese salad skewers. Ingredients: cherry tomatoes, fresh mozzarella balls, fresh basil leaves, balsamic glaze, olive oil, salt, and pepper. Instructions: thread a cherry tomato, a basil leaf, and a mozzarella ball onto small skewers. Drizzle with olive oil and balsamic glaze, then season with salt and pepper. This dish is light, refreshing, and easy to prepare ahead of time. Main course: herb-crusted salmon with lemon asparagus. Ingredients: salmon fillets, fresh herbs such as parsley, dill, and thyme, breadcrumbs, lemon, asparagus, olive oil, salt, and pepper. Instructions: preheat your oven to 400 degrees Fahrenheit, 200 degrees Celsius. Mix breadcrumbs with chopped fresh herbs and a bit of olive oil to form a paste. Pepper. This dish is light, refreshing, and easy to prepare ahead of time. Main course: herb-crusted salmon with lemon asparagus. Ingredients: salmon fillets, fresh herbs such as parsley, dill, and thyme, breadcrumbs, lemon, asparagus, olive oil, salt, and pepper. Instructions: preheat your oven to 400 degrees Fahrenheit, 200 degrees Celsius. Mix breadcrumbs with chopped fresh herbs and a bit of olive oil to form a paste. Press this mixture onto the salmon fillets and season with salt and pepper. Place salmon on a baking sheet and bake for about 15 to 20 minutes, or until cooked through. In the last 10 minutes of cooking, toss asparagus with olive oil, lemon zest, salt, and pepper and roast alongside the salmon. Serve with a squeeze of fresh lemon juice over the salmon and asparagus. Dessert: chocolate mousse with fresh berries. Ingredients: dark chocolate, eggs, sugar, heavy cream, vanilla extract, and mixed berries such as strawberries, blueberries, and raspberries. Instructions: melt the chocolate over a double boiler, then let it cool slightly. Separate egg yolks and whites. Whip the egg whites to soft peaks, then gradually add sugar to make a meringue. Whip the heavy cream until soft peaks form and mix in vanilla extract. Fold the melted chocolate into the egg yolks, then gently fold in the whipped cream and meringue until combined. Spoon the mousse into serving dishes and refrigerate for at least 2 hours. Serve topped with fresh berries for a burst of color and freshness. Additional tips: pairings. Consider serving a light white wine with the appetizer and main course, and perhaps a dessert wine with the chocolate mousse. Timing: prepare the appetizer and dessert in advance to minimize last-minute stress. The main course will take the most time in the oven, so plan accordingly. This menu is designed to be elegant yet approachable, ensuring your guests enjoy both the food and the experience. Enjoy your dinner party. Hosting a dinner party is a wonderful opportunity to showcase your culinary skills and create memorable experiences for your guests. To help you plan a great meal, here are a few questions that can guide you in choosing the perfect menu. Dietary preferences/restrictions. Are any of your guests vegetarian, vegan, gluten-free, or have any food allergies or intolerances? Knowing this will help in selecting dishes. Specify the desired format for responses. When you want the model to generate output in a specific format, you can provide a template or structure in your prompt. For example, if you're a sports reporter composing a historical article, you can request that the model follow a specific template, which includes headings, bullet points, and data breakdowns. Expand table. No template specified. With template specified. A system prompt. You're a helpful AI assistant. You're a helpful AI assistant for sports reporters. User prompt. What happened in the 2018 Soccer World Cup final? What happened in the 2018 Soccer World Cup final? Format the result to show the match date, location, and the 2 teams competing, then the final score, and finally any notable events that occurred during the match. Model response. The 2018 FIFA World Cup final took place on July 15, 2018. You can apply this approach to other scenarios where a specific format is needed, such as generating emails, summaries, proposals, or even code and scripts. Define the format template clearly and provide details on how you want the output structure to get consistent and organized responses. You can also use a one-shot or few shots approach by providing one or more examples to help the model identify a desired pattern. Ask for an explanation of reasoning. When you want the model to explain the reasoning behind its answers, you can ask the model to automatically reflect on its rationale and assumptions after providing a response. For example, if you're working on a mathematical problem, you can ask the model to explain the reasoning behind specific calculations. Expand table. No reflection specified. With reflection specified. A system prompt. You're an AI math assistant. You're an AI math assistant. You always explain your answers. User prompt. A right-angled triangle has a hypotenuse side of length 3 centimeters and an adjacent side length of 2 cm. What is the length of the remaining side? A right-angled triangle has a hypotenuse side of length 3 centimeters and an adjacent side length of 2 cm. What is the length of the remaining side? Model response. Approximately 2.24 centimeters. We can use the Pythagorean theorem to solve this problem. The Pythagorean theorem states that in a right-angled triangle, the square of the length of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the lengths of the other two sides. Mathematically, this can be written as You can apply this approach when you want explanations in data analysis, marketing strategy, or technical troubleshooting. When you ask the model to define its reasoning, you use a technique called chain of thought to make it think step by step. Add context. When you want the model to focus on specific topics, you can specify the context to consider. You can also tell the model to ignore irrelevant information. For example, if you're planning a trip, you can provide the model with more context to help improve the relevance of its response. Expand table. No context specified. With context specified. A system prompt. You're an AI travel assistant. You're an AI travel assistant. User question. When should I visit Edinburgh? When should I visit Edinburgh? I'm particularly interested in attending Scotland's home matches in the Six Nations rugby tournament. Model response. Edinburgh, the capital city of Scotland, is a wonderful destination with a rich history and By defining what the model should focus on or disregard, you can ensure the conversation stays on track and generate more relevant, tailored responses. You can specify the context by describing what it should or shouldn't include, and by connecting the model to data sources it should retrieve context from before generating an answer. Apply model optimization strategies. Note. This section discusses options and considerations for model optimization that you may consider beyond prompt engineering. A full exploration of how to apply these optimization strategies is beyond the scope of this module. Prompt engineering can be an effective way to optimize model responses, but in some cases it may not provide sufficient context or guidance to always meet your exact needs. As a developer, you can consider the following additional optimization strategies to improve the relevance of your generative AI application's responses. Retrieval augmented generation, RAG, a technique that involves using a data source to provide grounding context to prompts. RAG can be a useful approach when you need the model to answer questions based on a specific knowledge domain, or when you need the model to consider information related to events that occurred after the training data on which the model is based. Fine-tuning, a technique that involves extending the training of a foundation model by providing example prompts and responses that reflect the desired output format and style. Both of these approaches involve additional cost, complexity, and maintainability challenges, so as a general rule, it's best to start your optimization efforts through prompt engineering and then consider additional strategies, if necessary. The strategy you should choose as a developer depends on your requirements. Optimize for context, when the model lacks contextual knowledge and you want to maximize responses accuracy. Optimize the model, when you want to improve the response format, style, or speech by maximizing consistency of behavior. To optimize for context, you can apply a retrieval augmented generation, RAG, pattern. With RAG, you ground your data by first retrieving context from a data source before generating a response. For example, you want employees to ask questions about expense claim processes and limits based on your own corporation's expenses policy documentation. When you want the model to respond in a specific style or format, you can instruct the model to do so by adding guidelines in a system message. When you notice the model's behavior isn't consistent, you can further enforce consistency in behavior by fine-tuning a model. With fine-tuning, you train a base language model on a dataset of example prompts and responses before integrating it in your application, with the result that the fine-tuned model will produce responses that are consistent with the examples in the fine-tuning training dataset. You can use any combination of optimization strategies. For example, optimize for context, when the model lacks contextual knowledge and you want to maximize responses accuracy. Optimize the model, when you want to improve the response format, style, or speech by maximizing consistency of behavior. To optimize for context, you can apply a retrieval augmented generation, RAG, pattern. With RAG, you ground your data by first retrieving context from a data source before generating a response. For example, you want employees to ask questions about expense claim processes and limits based on your own corporation's expenses policy documentation. When you want the model to respond in a specific style or format, you can instruct the model to do so by adding guidelines in a system message. When you notice the model's behavior isn't consistent, you can further enforce consistency in behavior by fine-tuning a model. With fine-tuning, you train a base language model on a dataset of example prompts and responses before integrating it in your application, with the result that the fine-tuned model will produce responses that are consistent with the examples in the fine-tuning training dataset. You can use any combination of optimization strategies, for example prompt engineering, RAG, and a fine-tuned model to improve your language application. Next unit. Exercise. Explore, deploy, and chat with language models. Previous next. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. And follow the instructions. Next unit. Module assessment. Previous next. Need help? See our troubleshooting guide or provide